continuation of the first video, we are just going to be going over some more rules. They are pretty basic, pretty straightforward, of some rules that deal with derivatives. So they are the constant rule, the sum and difference rule, and the constant multiple rule. At this point, you've already learned about the power rule and how it functions. These rules come along with that. So the constant multiple rule basically says that the derivative of a constant function is 0. That is, given c is a real number, and if f of x equals c, then f prime of x is equal to 0. So that basically means that whenever you're given just a number like 2 or -4, and you're asked to take the derivative of it, it is always 0. Okay? So the derivative of a constant is always 0. The sum and difference rule basically says that if you have a function that's basically comprised of many functions put together by either an addition sign or subtraction sign, you just take the derivative of each individual piece of that function. Then the constant multiple rule says that if there is a number in front of your function, then the derivative of that is basically the constant times the derivative of that function. So I'm going to show you a few examples, and so that way you can see exactly how these rules work. So here in this very first example, you're asked to find f prime of x, given that f of x is 7x squared. This one is an example of the constant multiple rule, and the reason why that is because you have basically your function of x squared. You have your function x squared, but then there's a 7 in front of it. So then to basically work this out, you would do the derivative of the x squared part. Now, from using power rule, which you guys learned about, the derivative of x squared is 2x. The reason why is because, remember, you always bring the exponent down to the front, and then you would subtract 1 from your exponent. Okay? So that is your derivative of x squared. But because there's a 7 in front, the constant multiple rule basically says that you just multiply the constant by the derivative of the function. And so then your derivative would just be 14x. So 14x would represent the derivative of this particular function. Okay? It's pretty straightforward, pretty simple. Okay, let's look at this one. This one's applying the constant multiple rule and the sum and difference rule. Okay, the reason why is because you have the subtraction sign there in between this function 1/2 x to the 4th and 6x squared. But it is not any harder, it just means that you have to do the derivative twice, because you have to do the derivative for the left part and then the derivative for the right part. If I had an additional something afterwards, I would do it for that part as well. So you apply the power rule and the constant multiple rule to the first part. So we're going to leave the 1/2 as it is, but we're going to multiply it by whatever the derivative of x to the 4th is. Using the power rule, you bring down the exponent, and then you subtract 1 from your exponent. And so then that's going to give you 1/2 of 4, which is 2x to the 3rd for just this part. We're going to do the same thing for 6x squared. We're going to leave the 6 out there, and then we're going to do the derivative of x squared, which we just did in the last problem, which was just 2x, and then we'll get 12x. So then the derivative of this function, derivative of this whole function right here, is just going to be 2x to the 3rd minus 12x. The minus stays there because it was originally subtraction, and the derivative of 6x squared was a positive 12x, so then it still stays a minus. Let's look at this one. This was incorporating what we did with the power rule whenever you have a radical involved, and we have a constant now. So I'm going to start out first by rewriting my my radical as a rational exponent. So that's really x to the 1/3. So this is nothing but 3 times x to the 1/3. And so then I'm going to leave the 3 out there, and then I'm going to multiply it by the derivative of the x to the 1/3. So I bring down the exponent, which is 1/3, and then I subtract 1 from your exponent. Now because of this, this is going to give me a negative number there. 3 times 1/3 is just 1. This is going to give me x raised to the -2/3, and we cannot have any negative exponents here. So then to make it positive, we bring it down to the denominator, and we make it positive using our laws of exponents there. So then what we have here, that 1 over and I know it's kind of hard to see because I am using my typing feature here. 1 over x to the 2/3 would be my derivative. Now, yes, you can leave that 2/3 the way it is, or you can rewrite it in radical form. To be honest, it kind of really doesn't matter. So it's more so up to you. And then that would be the derivative there. I'm going to do one more with you guys, and then I'm going to put up a few more problems, and I'm going to pause the video, let you guys try them out, and then you press play when you're ready to see the answer. Now, in situations like this, there is a rule that is involved when you actually have like a function divided by another function, but you want to look to see, is there a possible way I could actually simplify this first before before we take the derivative? And because this is just an x in the denominator, we really could divide every single one of these pieces in the numerator by x. Okay, so that's basically like taking the one fraction and dividing it into three fractions. So when we do that, then that actually means that our function is really x to the second plus 1 minus 3 over x. That's really what this function is when I divide every single term by x. Now, of course, we don't want that x in the denominator of that 3 over x, so then we can rewrite this as x squared plus 1 minus 3 to the 3x raised to the negative 1. That's what we did back in with the power rule notes. Whenever you have a denominator, you want to bring it up to the numerator so that way you can apply the power rule. And then we just apply our power rule to each one of these pieces. This is the sum and difference rule, power rule, and actually our constant rule, because 1 is a constant. So the derivative of x squared is just 2x. We've done that enough times. And then the derivative of 1, just like the derivative of any constant, would be 0. And then we apply the power rule to the next part. Now, since there's already a negative there, we're going to have that, or since there's already a minus there, we're going to have a minus 3. Then we're going to multiply by the derivative of x to the negative 1. I bring down that negative 1, and then I subtract 1 from my exponent. So then that's going to leave me with negative 3 times negative 1, which is a positive 3. I went ahead and just dropped the 0. Hopefully everyone's okay with that. X to the negative 2. And then, of course, I don't want any negative exponents, so then I'm going to rewrite it so that my exponent is positive. So the derivative of this function, this one that had x to the third plus x minus 3 all over x, is actually going to be 2x plus 3 over x squared. And that is the derivative of this particular function. I'm going to put up a few more problems. I want you guys to try them on your own, and when you're ready to see the answer, press play. You have x plus 2 to the third power. If you want a hint, try to expand this binomial and then take the derivative. Hopefully when you expanded, you got x to the third plus 2x squared plus 4x plus 8. When you expand it using binomial theorem, or just multiplying x plus 2 by itself 3 times. And then you use the power rule and the sum and difference rule, and you get 3x squared plus 4x plus 4, because the derivative of 8, that constant, is always 0. Here's your next one. You are going to have to use your laws of exponents here before you can actually take the derivative. Remember, differentiate means to basically take the derivative of that function. Hopefully for this one, you got 3 over 2x to the 1/2, because you rewrote the square root of x as x to the 1/2. And when you multiply with the same base, you add your exponents. So then the function simplified would have been x to the 3/2. So you bring the 3/2 to the front, subtract 1 from your exponent, and then that's how you get your derivative. Here's the next one. Your hint, simplify before you take the derivative. And when you simplified, you should have gotten 2x minus 3x to the third, because remember, your loss of exponents says that when you divide with the same base, you subtract the exponents. So then the derivative should have been 2 minus 9x squared. Pause the video so you can try this one. So for this one, you did have to do a little bit of work with the derivative. For me, I started by rewriting the function so that you had x to the negative 2 plus 6x to the 1/2. So then when I took the derivative, I brought down the negative 2, subtracted 1 from your exponent. Same thing, I brought down the 1/2, subtracted 1 from the exponent to get a negative 1/2. And then when I simplified, remember, the only part that's negative is the x, is the base. So only the x went to the bottom, not the 2 and not the 3 once you multiplied 6 by 1/2. So your derivative should have been negative 2 over x to the third plus 3x to the 1/2. And so that's how you use your different rules to find the derivative, okay? Now, when it asks you to find the gradient of the tangent to a function at a particular point, that is when you actually plug in the value for x into your derivative. So for this particular example, I want to find the derivative. Remember, y prime is another way to represent the derivative. Using the power rule, I get 4x minus 3 because, of course, the derivative of 7, which is a constant, is always 0. And so now I can actually find the slope of the tangent line at the particular point of negative 1 by basically doing y prime of negative 1, which basically just means I plug negative 1 in for x and I solve. So then the gradient at negative 1 is going to be negative 7. And that's it. The hardest that this can get really depends on the original function that you're given that you'll have to take the derivative of. So why don't you go ahead and try the last few on your own. Pause the video, press play when you're ready to see the answer. So this time you are actually getting a value that represents the gradient. For this, when you go ahead and take the derivative, your derivative should have been 8 over x to the third, and you can see my work right above it. So then when you evaluate it at 4, even though they gave you the point, remember you only plug in the x value, and you'll get 1 over 8 as your gradient. This one is a little bit more involved. I did want to give you this problem just to make sure that you guys see if you guys really got the whole concept of plugging in the value, okay? So it says, suppose you have this function that b plus 1 is a constant, just like that c is a constant. It says f of 2 is equal to 4, and f prime of negative 1 is equal to 2. Pause this video, see if you can give it a try, and then when you're ready to see the answer, press play. So to start out, that f of 2 basically means that you plug 2 into the function and you're going to equal it to 4. So that means that I'm going to plug in 2 for all my x's. Okay, remember b plus 1 is a constant. That's going to get multiplied by 2 here. And all this is going to be equal to 4. Okay, now this can simplify, of course. So it's going to give me 4 plus 2b plus 2 plus 2c is equal to 4. I can continue to simplify this down a little bit more to get 2b plus 2c plus 6 is equal to 4. And then, of course, that does simplify down to be 2b plus 2c is going to be equal to negative 2. Now this other part, this part that says that f prime of negative 1 is equal to 2, remember that f prime notation means the derivative. So you were wanting to take the derivative of the function that you have, of the original function, and set it equal to 2. So the derivative of x squared is 2x. The next part, that b plus 1, x, remember b plus 1 is a constant. A constant times x, when you take the derivative, just leaves you with the constant. So you should have just had b plus 1. And then 2c, well, c is a constant times a constant is constant, which will give you 0 when you take the derivative of it. So all that was going to be equal to 2. So then you actually had to plug in negative 1 in for x into your derivative, and then set it equal to 2 and simplify from there. So that would have given you negative 2 plus b plus 1 is equal to 2. And then when I simplify it again some more, that would give me b minus 1 is equal to 2. So then b, if I solve this, would be equal to 3. It did ask me to find the constants of b and c. I just found b to be 3. So then I used that to plug it back in over here into the original function when I plugged in 2. So 2 times 3 plus 2c is equal to negative 2, Well, 2 times 3 is 6. When I subtract 6 over, that's going to give me a 2c equals at negative 8. And then c would equal negative 4. So here's a problem that's a little bit more involved that just does deal with derivatives and evaluating a derivative at a particular value. Hopefully these extra examples helped out and will help you as you go along in the next part of derivatives.